Welcome all. This is Karim. Well, uh, we should continue working with this series of statistics with most frequent question we're gonna fixing in some interview. Well, let's continue. So after the ending of this series or the theoretical series, say we're working with the exercises and real scenario, and we show you how we can use in the statistics to making decisions. Okay, well. Let's see this first question with this new notebook we have here. So what is the p-value in hypothesis testing? Well, if you look in these two parts of answers we have, well, if p-value is more than critical value, then we fail to reject the h0. Well, for p-value is just probability. Okay, I will show you that deeply when we working with exercises. Well, if p-value is more than critical value, then we fail to reject this h0. If p-value here, we are taking just two small examples here to show you that if p-value is equal to 0.015, so in this case, and we have this critical value is 0.05, I mean alpha, here is by default or default value here is 0.05. This is strong evidence. That means we fail to reject that. Why? Because the critical value is less than the p-value or the probability we found. Same things with the second example we have here. If p-value is equal to 0.055 and the critical value is 0.05, I mean we can now reject the h0. Okay. Here, if we are looking the second part of these questions or these answers of this question, we have if p-value is less than the critical value, then we reject h0. I mean, if we have the critical value is more than the probability found, I mean the p-value at this time, we need to reject h0 and accept the alternate hypothesis. Well, if we look in this example we have here, if p-value is equal to 0.005 and we have this critical value is 0.05, it's a strong evidence. I mean, we need to reject okay our null hypothesis is zero. Maybe it's clear. So with these small examples, I mean this question is clear because here we just try to compare two values, the probability one and the critical value. Well, if we go to the second questions here, the second question, sorry, how do we calculate p-value using manual method? I mean, um, to calculating or to determine the value of p-value, we have steps to follow to do that. So the first one is to find h1 and h0. I mean here we need to formulate our null and alternate hypothesis. Okay, we cannot find the value or to answer some questions depend on informational statistic without try to formulate h0 and h1. That is necessary. This is the first step we need to do here. The second one or the second part or the second step here in this algorithm with brackets is to find n. N, I mean the number of elements we have in simples. Because here, when we're talking about h0, h1, we mean about that simple. We're working with international statistics, not the population. Okay, for the reason we need to determine the number or the value of n, the number of elements we have in simple. And also here we need to calculate in the x bar. X bar, the average or the mean of this simple. And the third parameters or the third measure we need to determine is the standard deviation of simple, because S here, the symbol of S, the mean standard deviation of simple, not standard deviation of population. Okay. The third step here is to find the degree of freedom. We're talking about this concept in the last sessions. Degree of freedom, we mean by that it's the number of elements we have in simple minus one. Okay. Here, so we're talking about degree of freedom if we have T distribution, not Z distribution, because in T distribution we don't have standard deviation, we don't have average of population. Okay, start step here. I need to permit two steps here. Maybe before trying to find in degree of freedom, we need firstly find the type of distribution we have here. Well, if we have T distribution, we mean by that we don't have standard deviation of population, we don't have average of population. We need just to find the number of elements we have in our sample to calculate in the X bar. I mean by that average of sample, and the type parameter is given in exercise. We can find it. It's standard deviation of sample. Well, the Z distribution, that means we have standard deviation of population. Okay, I hope that's clear. Well, find T or Z value, because T or Z value we can find it with a log table. Okay, I will show you that after. Where here we can find the value of T and Z in tables. After we look in the tables of T or Z, and we see the intersection of the values we have in the columns and the row. This time we're gonna find the value of T or Z. And the last step here is to compute the p-value. After determining all these measures here, the last step is to compute the p-value. I mean the probability we have. Well, and compare it with the critical value. See if it's less or more. That's depend. Okay. I hope that's these steps is clear for you to calculating the p-value well. And we go to third question here. So how we calculating p-value using Excel? Well, we have a lot of tools to do that. We can use in Excel, we can use in Python, we can use in R, we can use in Scala. We have now Mojo, we have Julia, we have a lot of we have SAS, SSP, we have a lot of tools to use it to do that. But the most important thing here is to have strong background, okay, strong background and domain knowledge to understand what's happening here. That's help us more to making the right decisions. Well, if you look in Excel here, as we see with me, so I taking this random example here. Okay, we have person code here. Okay, we have weight and we have net results. Well, to do that in Excel, we can just go to data. Okay, here in Excel, whatever the version we have, we can just look in the data where is it, or we can add it. Okay, I will put for you the link of Excel for to add in this data in our menu if it doesn't exist, if not exist, sorry. Well, for in our case here, what we can do is to go to data. After that, we can go to here. I mean, data analysis tool. So we click in, okay, and here. So first, well, I will firstly determine this descriptive statistics. Okay. Well, look in here. Well, I will choose in this one here. Okay, this weights. I will just show you with Excel how we can do that descriptive statistics. Well, output also I will change it. Well, just choosing other empty cells. Okay, well, if we're looking at okay, okay. So we need to see the summary statistics. And we have also this confidence level of mean it's by default is 95%. Well, if we click OK, this time we can see all the measures of uh, this variable we have here. Okay. Well, we have mean of this value. I mean this weights column. Here we have the mean. We have standard error. So we have median. This is the mode value. Okay. Well, we have also the standard deviation. We have simple variation. We have KTUs, we have sickness, we have range, maximum, minimum, sum count. We have all descriptive statistics. Okay, all descriptive statistics here. So on other side, we can also do or calculating the p-value here by clicking again this data analysis tools. Well, uh, here we go in this test here because we don't have average or the standard deviation population. So we choose this test here too simple for me. We click OK. Here we are tracing the first variable here in our case is weight. Okay, it's okay. Second variable is doesn't need result here. Well, we have alpha is 0.05 by default, and also here we need to trace in another range or other output empty cells. So well, they were choosing randomly. That's okay. Okay. When I click OK, I will see the results here. Well, um, here we have variable one and variable two. We can see can compare the means of two variables we have here. So for variable one, I mean width, and for net result also here. Okay, we have variance between two variables. So here we have number of observation. We have 10. Both variables have just 10 samples or 10 elements in each variable. We have percent correlation. Hypothesis, we have degree of freedom is 9 because it's 10 minus 1 as I said before. Well, we have this 36, this is this value, and we have this is p-value here. Okay, we have p-value here and here. So I need to transform it to percentage to show you that how that is important. Well, we'll go here. Where is this? Okay. Well, this format. Oh, there is. Well, I will click in here. Transform it to percentage. We have 2%, and also for these two, we have one tail and two tail here. Okay. Well, I click also here. This is 5%. Well, if we look in here, when between two and one tail, we have difference maybe of 2%. I mean, here 2% and here 4%. At this time, we can now reject our null hypothesis. Why? Because this one tail is less than what we get in here in p-value. Okay. Well, this time we can now reject in each one or sorry each zero. Okay, because one tail test here is more or less than two tail test. Okay, just I show you here is a small example, show you how you can also use in Excel. So it's a powerful tool, can pass through a lot of things. Well, I will show you that with Python also. When we go in the part or practical part, well, we show you that more deeply. So if we return to our questions, so if we go to a fourth question, what do you mean by making decisions based on comparing p-value with significance level? Here, because to making decisions, we can see two things: the value of p-value or the value of p-value, yeah, and the level of significance. I mean the alpha or critical value. If p-value is more than critical value, okay, if we calculate in p and we found this value in p-value is more than critical value, I mean alpha, okay, by default is 0.05. If this value of p-value is more than critical value of alpha, then we fail to reject h0. I mean we accept the null hypothesis. But in case of p-value is less than critical value, then we reject h0. I mean the probability, if we found the probability is less than the critical value we given by default at this time, we need to accept h0, not to reject it. When we go to another questions, 5 questions. So what is the difference between one tail and two tail hypothesis testing? Because we have So for this test tail, we have one tail and two tail. Well, for two tail test, critical region is on both sides of distribution. Okay, here I will show you this graph here. So what we mean about, or what we mean by this two tail test, I mean both of sides, left hand one and the right one. That means this probability of or significance level or the criteria or alpha we give, it will be divided by 2. If taking for example 0.5, at this time we need to divide it by 2, and we have found yes, alpha divided by 2 is equal to 0.005. So the same value in both of sides. Okay, that's what we mean by two test tail. Okay, uh, well, two tail is so critical region on both sides of distribution. Well, H0 or nil hypothesis average or x bar here is equal to mu. See the mean here in both sides, left and right one. For each one is the inverse of the each one. The mean uh, x, it will be different to mu. Okay, it will be different if this h0 is equal to mu. The mean both sides, but here it's different. But if we look in one tail test, the critical region is one side distribution. I mean, so if you look in h0 here, x bar is will be less or equal to mu. Okay, it will be less or equal to I mean just one side. But for each one x bar, it will be greater than mu. It will be greater than. Okay? For one side, I mean just we look in here or here. We need just to look in for left side or right side. But in two tail test, we are just interested in both sides, and the probability it will be just here in this graph. This is the interval here. And if you look in this value we have here is minus 1.96, and also we have 1.96. This is the interval we have here. Okay, the interval confidence interval is here. Okay, anything it's coming over in this place or out or extreme of this interval, it will be rejected. That's what's called the null hypothesis. Okay, I hope that's clear for you. Well, if we look in the next question here, what do you think of one of the tail, one or two tail, if h0 is equal to one value only? Here in this question, uh, what do you think of the tail test? Okay, one or two tail, if h0, I mean null hypothesis, is equal just one value, not greater, not less. At this time, it's two tail test because as we see here, h0, okay, h0 here is x equal to mu. I mean, this is only one value, but here in the analysis, it's care about both of sides, left and right. Okay. Seventh question: what is the critical value in one tail or two tail test? Critical value in one tail is alpha. Okay, because if we have just one tail test, I mean we care about left or right side. I mean here the alpha is just will be it be just this the value of alpha, it will be here or here. So in this case we have divided by 2 because it's two tail test, but in case of one tail test 5% will be here or here. Okay, I hope that's clear for you. Well, uh yeah, here in one tail test, but critical value in two tail test, it's alpha divided by 2. Okay, if we care about if our null hypothesis h0 x equal to some value at this time, we need to divide this value here, this alpha, it will be divided by 2 because we have right one and side, and we need to determine our interval. I hope that's clear for you. Okay, well, this graph show you this one more clear. Okay, here alpha divided by 2 is equal to this value, and also here. Okay, that is case of two-tailed test. Well, maybe the last question here in this series or this session. Question 8: why is the t-value sum for 9% two-tailed and 95% on one-tailed test? Here, so p-value of one tail test is equal to p-value of two tail test, because here that's different. Okay, the same value, the same critical value. If we look in one tail test or two tail test, we have the same value, because the critical value here is divided by 2, because we have two tails, we care about both sides. But in case of one tail test, we have just one. That's why. So it's because in two tail there are two critical regions. That's why. Okay, the t-value same for 9% total and 95% tail. We have same value because in case two tail we care about two sides, but in one tail we care about just one side, left or right. That's different. So I hope that's clear for you all, and happy learning for everyone. Okay, so I will still continue in this uh, series of questions. So after that, I will show you the practice of all these things, how called using the statistics, because that is important. Well, in the area of the science, we have two schools. We have some schools believe in statistics, okay, and we have the other schools not believe in statistics. I mean, in this area of data science and machine learning, is not um, is not consider statistics as a pillar of this field. Okay, but for me, I believe in that statistics is important to do that, because we have modeling, we have a lot of things to do using statistics. That's why it's very important to do that. Well, so for some tools, it's big fun with statistics like R. Okay, like R tools are the languages of statistics is famous by statistics, and with this tool, so we can now kind of predict, kind of building our models to make predictions. And also we have Python. Okay, or Python. So it's not like R in the part of statistics. Okay, because this school is not believe more in statistics, but still important. Okay, well, so I hope that this point is clear for you. Okay, I will still continuing that. So after finishing of this series of theoretical part, I will go to the practice to show you that's how it's important. Also in Python we have libraries can perform a lot of functions in statistics. Okay, in relational statistics and descriptive also. After that I will go to show you more tools to in data science. Okay. I hope that's clear for you, and see you again in the next tutorials. Bye bye.